Okay, let's start with section 2. We have right triangles and we have trigonometry. So, numbers 1 and 2 are just some simple Pythagorean theorem problems. So, of course, our Pythagorean theorem is a squared plus b squared equals c squared. They give us a equals 8. And they give us c equals 11. Literally, plug it in. 64 plus b squared equals 11 squared. Sorry, I cheated a little there. We all know 8 squared is 64, right? So 64 plus b squared equals 121. Let's subtract the 64. B squared equals 57. We all know that we need to get rid of the square sign. So we all know how to get rid of that by using the square root. So we end up with b equals square root of 57. Nope, we're going to keep it as a radical. The question was, do we turn it into a decimal? No. All your multiple choice options will be in radical form on your final. Okay? So we need to remember how to simplify. Are there any perfect squares in 57? Is 4 divisible with 57? Nope. Is 9? Nope. Is 16? Nope. 25? Nope. To be honest, 57 is a prime number. That's my final answer. Number 2. Number 2, once again, we have a equals 16 and b equals square root of 19. We need to find c. So, let's plug it in. 16 squared plus square root of 19 squared equals c squared. Everyone's probably in freak out mode because they see this square root of 19, but this is actually, freak out mode doesn't need to be happening right now because I know that a square and a radical cancel each other out. So that just cleans up to be a plain old 19. 16 squared. 256.
Yeah.
Equals c squared. Let's collect our like terms and we end up with 275 equals c squared. We have a radical square once again. Good news is we know how to get rid of that. And I know for a fact that there is a perfect square in 275. I know one of my perfect squares is a 25. When I see something ending with a 75, 25 is going to jump into my brain right away. Think money here. We got quarters. 3 quarters makes 75 cents. So obviously 25 goes into it. How many times?
3.
11. You had 75 cents in your head, Ashley. I get you. So we end up with 5 square root of 11. Because the 25 is a perfect square of 5. Okay, let's look at number 3. Alexei walks 2.5 meters south. Where's south? That is what? Down. And 4.7 meters east. I don't really care if you don't know east is left or right. All we need to care about is the horizontal piece. Obviously, my picture is not in scale since my 4.7 is shorter than the 2.5. but small details. So, Alexi walks. How much did she walk? She walked 2.5 down and 4.7 over. So she walked a total of 7.2 meters. So that's Alexi. Well, her sister decided to cut some corners and just swim across the lake. I don't know, but I think this is a coincidence that I just made a right triangle in a right triangle section. And we know the Pythagorean theorem to solve this. Her sister's swim is the hypotenuse. Alexi walking is my A and my B. 2.5 squared plus 4.7 squared equals C squared. 2.5 squared is 6.25. Selena, you had a question? No? Oh. 4.7 squared is 22.09. Let's collect those like terms. 28.34. And then let's square roots. Alexi's sister swam 5.32 miles. Sorry, meters. Okay, but we haven't quite answered the question. How many meters to the nearest tenth did Alexi's sister save by swimming? Okay? I hear little whispers in the background, and I concur with that whisper, and that needs to be subtract that number with this number. 7.2 minus 5.3. Lexi's sister saves 1.9 meters. Yes, Ashley?
The board has 1.8. Yeah.
Hmm?
Your board's off. You didn't round it on the board.
Okay. Are we all good? Oh, okay. It's the same thing. Number 4. Number 4, we're going to get into the SOHCAHTOA world. Number 4, we're going to get into the SOHCAHTOA world. Let's look at the angle that's given to us, which is the 42. We all know that this x right away, since it's across from the 90-degree angle, is my h. Now I got to figure out if this 25 is across the street or next door. We all know that this is across the street. So this is the opposite. I have an O and an H. I'm going to use sine. Sine of 25 equals O over H, 25 over X. Why did I put a 25? I don't know. I think it's a 42. I got you. Okay, and we're back. Okay, now notice how the variable is on the bottom. There is something special we have to do here. When we solve for x, we need to divide. So, 25 divided by sine 42 gives me 37.4. Number 5. Once again, know this. you don't know SOHCAHTOA, this section is going to be a little rough. Here's the angle. The 14 is across from the 90-degree angle. I know that is H. Now let's look at the other thing that's labeled. X is next door. So this is adjacent. So I'm going to use cosine. Cosine of 31 equals x over 14 . 31 cosine times 14 is a plain old 12. The good news is, when the variable is on the top, you just cross multiply these guys and it gives you your answer right away. So, 4 and 5 were missing sides. What happens when we find missing angles? We use our inverse. So, here's my question mark. 18's across the street. 25 is next door. Hypotenuse is not even labeled, so I'm going to use tangent. So, tan of x equals O over A. Let's get familiar with our calculator once again. Where's that button located? It's above the tangent. We use these three right here when we're trying to find the missing angle. So, second tan. Should have a -1 that shows up. Literally, put in that fraction right into your calculator. We end up with nearest tenth. Did I do that up there? Yeah, 35.8 degrees. Once again, missing angle, we're going to use those buttons up there. Number 7, once again, another missing angle. Eight, 19 is across from the 90-degree angle, so though I know that is H. 12 is across the street, so that is O. I have O and H, so I'm going to use sine. Second sine of literally that fraction that you just set up. Oop. Press enter. You end up with 39.2 degrees. Okay, number 8. Number 8 is kind of complex. Number 8, find the area of the given triangle. We know the formula for area of a triangle is 1/2 base times height. Here is my height. Here is my base. This 19 degrees is not the height, it's this angle right here. This 12 is only from here to here. I need to figure out what this is. So, first thing, let's find the height. Here's my angle. The 12 is my opposite. My height is my adjacent. I'm going to use tangent to find that height. Tangent of 48. 12 over x.
What height are you trying to find?
This height right here.
Don't we already know what that is?
That 19 degrees, once again, is not this. It is this angle right here. You can't really see it, but that little dot right there is a degree mark. Since the variable's on the bottom, I need to divide by that tangent, and I end up with 10.8. So I just found this to be 10.8. So now I need to use this 19 degrees and this 10.8 to find this guy. So I'm going to have to use tangent once again. Tangent of 19 equals, this time, x over 10.8. Tangent of 19 times 10.8, we end up with 3.7. So that means that's 3.7, making the whole base 15.7. Plus 3.7. Now, let's plug everything in. And we end up with an answer of 84.8. Yes, I have 0.75 up there, but we round to the nearest tenth like it says. Yes, this is a complicated one. You have to do trig twice. Okay, I need to hustle a little, don't I? Number 9. Tom delivers paper on a route from his car. If he throws the paper from a height of 5 feet and it lands 12 feet from the car, at what angle of oppression did he throw the paper to the nearest degree? So, Tom is in a car window. That's 5 feet from the ground. He throws a paper. Well, just 12 feet from the ground. Conveniently, there is a right triangle right here. Angle of depression, that is this angle right here. But since we know that these two lines right here are parallel lines, this angle of depression is also right here. They want us to find that angle. This is opposite, this is adjacent. I'm going to use tangent. My angle is the unknown, so I'm once again going to use the inverse. 22.6 degrees. Number 10. There's a cell phone tower in the field across from Jin's house. If Jin, cell phone tower, let's just go ahead and draw that. Beautiful. If Jin walks 200 feet from the tower, so she starts at the tower and walks 200 feet. She looks at the top of the tower at an angle of elevation of 23 degrees. So she's here looking up at the tower at 23 degrees. How tall is the tower? Once again, SOHCAHTOA, opposite, adjacent. I'm going to use tangent, tan of the angle, which is 23 degrees, equals O over A, so X over 200. Variables on top, so all I need to do is multiply. 84.9. Number 11. A guy wire is attached to the top of a 25-meter tower. Tower, 25. A guy wire is attached to the top. Here's the wire attached to the top of the tower. It meets the ground at a 45-degree angle. How long is the wire? X is the hypotenuse. 25 is across the street, so it's opposite. So katoa, I'm going to use sine. O over H, 25 over X. I'm going to use I'm going to divide this guy by that guy to get my answer. 25 divided by sine of 45, 35.4. Once again, when the variable's on the bottom, you take this and divide it by that. That is when the variable's on bottom. Number 12. At a certain time, a tree that is 80 feet tall casts a shadow that is 30 feet long. Well, tree's tall, and its shadow is usually on the ground. What is the angle elevation of the sun? That's this guy right here. Opposite, adjacent. It's been an ongoing theme with these angle of elevation and depression that we use tangent. Angle's the unknown. O over A, so 80 over 30. The angle's the unknown, so we need to use the inverse button once again. Should have the -1. 80 divided by 30, 69.4 degrees. When a ladder is resting against a house, it forms a 35-degree angle with the ground. So, we have a ladder. Here's the outside of the house, the ladder leaning against it. It forms a 35-degree angle with the ground. The ladder is 15 feet. How high up the house does it reach? That's this guy. Once again, trig problem. 15 is the hypotenuse, across from the right angle. X is across the street, so it's opposite. I'm going to use sine. The variable's at the top. Good news. So that means all we have to do is multiply. Sine 35 times 15, we end up with 8.6. 14 and 15 are law of sine problems. So let's recall law of sine. Sine of big A over little a equals sine of big B over little b equals sine of big C over little c. Let's write everything out. What do we know? We know big A is 86 degrees. Now, how do we find little a, little b, little c? It's always across the street. So since this is big A, whatever's across from it is little a. So 16 is going to be little b or little c? Little c. They want us to find angle C. So here's what we're trying to find. So we're going to use this part of the law of sines. We're going to do sine of 86 over little a. Sine of C over little c. We're going to cross multiply and divide. So please watch what I do when I'm working on my calculator. I have sine of 86, close your parentheses, times the 16. You're going to divide by 20. You're going to get a crazy decimal. That is not quite our answer. We're trying to find big C. Okay? This crazy decimal is not my answer. This is actually the ratio of the sine. So to find our answer, we have to take second sine, because angle is our unknown. This crazy decimal was saved in your calculator as answer. So second answer, that's going to insert that decimal right there, right away for you, and you're going to get your answer of 52.9 degrees. It will tell you where it needs to round. Obviously, actually, you're going to have multiple choice options, so you're going to obviously see your answer depending on rounding or not. And finally, 15. Let's write out what we have. We have big C is 86 degrees. We have big B is 49 degrees. And we have little a is 19. We can't really set up a proportion yet because we don't have enough information. By the way, AB is what? Little c. But guess what? What do I know that this column adds up to every single time? 180 degrees. It is a triangle. So, let's go ahead and subtract 49 and 86, and we get 45 degrees. Guess what now? We can put sine A over little a and sine big C over little c to find our answer. Sine of 86 times 19 divided by sine of 45, I get 26.8. Good news is, that is my answer right away because it's a side. That's it for the right triangle and trig section.